Arrays in Java. Arrays. Arrays are objects that help us organize large amounts of information. In this presentation, we'll focus on array declaration and use, passing arrays and array elements as parameters, arrays as objects, sorting elements in an array, multidimensional arrays, the array list class, polygons and polylines, and more button components. An array is an ordered list of values. If you look at the examples below, the entire array has a single name of scores, and each value has a numeric index. An array of size n is indexed from 0 to n1. This array holds 10 values that are indexed from 0 to 9. A particular value in an array is referenced using the array name followed by the index in brackets. For example, scores within the brackets the number 2 refers to the value 94, the third value in the array. The expression represents a place to store a single integer and can be used whenever an integer value can be used. For example, an array element can be assigned a value, printed, or used in a calculation. Please look at the examples below. More on arrays. The values held in an array are called array elements. An array stores multiple values of the same type, or the element type. The element type can be a primitive type or an object reference. Therefore, we can create an array of integers, or an array of characters, or even an array of string objects, and so on. In Java, the array itself is an object. Therefore, the name of an array is an object reference variable, and the array itself must be instant initiated. Declaring arrays. The scores array could be declared as follows: int, open and close brackets, scores equals new int 10 inside of brackets. The type of the variable scores is int, open and close brackets, or an array of integers. Note that the type of the array does not specify its size, but each object of that type has a specific size. The reference variable scores is set to a new array object that can hold 10 integer. Some examples of array declarations. So please review the examples below. Take a few moments and look them over. Bounds checking. Once an array is created, it has a fixed size. An index used in an array reference must specify a valid element. That is, the index value must be in bounds, which is 0 to n1. The Java interpreter throws an array index out of bounds exception if an array index is out of bounds. This is called automatic bounds checking. For example, if the array codes can hold 100 values, it can be indexed using only the numbers 0 to 99. If count has the value 100, then the following reference will cause an exception to be thrown. System.out.println codes and then count. It's common to introduce off by 1 errors when using arrays. If you look at the example below, the circle in red and the problem is less than or equal to 100. Each array object has a public constant called length that stores the size of the array. It is referenced using the array name scores.length. Note that length holds the number of elements, not the largest index. Alternative array syntax. The brackets of the array type can be associated with the element type or with the name of the array. Therefore, the following declarations are equivalent. Float, open close brackets, prices. Float, prices, open close brackets. The first format, generally, is more readable. Initializer lists. The initializer list can be used to initiate and initialize an array in one step. The values are delimited by braces and separated by commas. Take a look at the examples below and how the code is written. Take a few moments and review the information. Note that when an initializer list is used, the new operator is not used and no size value is specified. The size of the array is determined by the number of items in the initializer list. The initializer list can also be used only in the array declaration. Arrays as parameters. An entire array can be passed as a parameter to a method. Like any other object, the reference to the array is passed, making the formal and actual parameters aliases of each other. Changing an array element within the method changes the original. An array element can be passed to a method as well and follows the parameter passing rules of that element's type. Arrays as objects. The elements of an array can be object references. The following declaration reserves space to store 25 references to string objects. String, open and close brackets, words equals new string and 25 inside the brackets. It does not create the string objects themselves. Each object stored in an array must be initiated separately. Command line arguments. The signature of the main method indicates that it takes an array of string objects as a parameter. These values come from command line arguments that are provided when the interpreter is invoked. For example, the following invocation of the interpreter passes an array of 3 string objects into main. These strings are stored at indexes 0 through 2 of the parameter. Arrays of objects. Objects can have arrays as instant variables. Many useful structures can be created with arrays and the objects. The software designer must determine carefully an organization of data and objects that makes sense for the situation. Let's discuss sorting. Sorting is the process of arranging a list of items in a particular order. We've done this since elementary school. We've sorted lists of homework. As adults, we've sorted grocery lists, items to-do lists, and so on. The sorting process is based on specific values. Sorting a list of test scores in ascending numeric order. Sorting a list of people alphabetically by last name. There are many algorithms for sorting a list of items. These algorithms vary in efficiency. During this presentation, we're going to examine two specific algorithms: selection sort and insertion sort. So what is selection sort? Well, it's the approach of selection sort. Select a value and put it in its final place into the list. Repeat for all other values. In more detail, find the smallest value in the list, switch it with the value in the first position, find the next smallest value in the list, switch it with the value in the second position, and repeat until all values are in their proper places. So here's an example of selection sort. You have your original line, which is 3, 9, 6, 1, and 2. The smallest is 1. Then smallest is 2, smallest is 3, and smallest is 6. So basically you're putting them in order: 1, 2, 3, 6, and 9. Swapping. Swapping is the process of exchanging two values. When swapping, this requires three assignment statements: temp equals first, first equals second, and second equals temp. Insertion sort. The approach of insertion sort is to pick any item and insert it into its proper place in a sorted sublist. You repeat this until all items have been inserted. In more detail, consider the first item to be a sorted sublist. Insert the second item into the sorted sublist, shifting the first item as needed to make room to insert the new addition. Insert the third item into the sorted sublist, shifting items as necessary. Again, repeat until all values are inserted into their proper positions. Here's an example of that. Again, you have your original line of 3, 9, 6, 1, 2. You insert 9, 6, then 1 and 2. And when you get down to the final line, you have your 1, 2, 3, 6, and 9. Sorting objects. Integers have an inherent order, but the ordering criteria of a collection of objects must be defined. Recall that a Java interface can be used as a type name and guarantees that a particular class implements particular methods. We can use the comparable interface and the compare_to method to develop a generic sort for a set of objects. Comparing sorts. Both selection and insertion sorts are similar in efficiency. They both have outer loops that scan all elements, and inner loops that compare the value of the outer loop with almost all values in the list. Approximately n to the second power number of comparisons are made to sort a list of size n. We therefore say that these sorts are of order n to the second. Other sorts are more efficient, order n log n. Two-dimensional arrays. A one-dimensional array stores a list of elements. A two-dimensional array can be thought of as a table of elements with rows and columns. If you look at the example below, you have a one-dimension array, which is basically looks like a list. And your the two-dimension array looks like a table. So you have not only multiple columns and rows, but you've now created what looks like a table. To be precise, a two-dimensional array in Java is an array of arrays. A two-dimensional array is declared by specifying the size of each dimension separately. Look at the example below. A two-dimensional array element is referred using two index values, as seen below. The array stored in one row or column can be specified using one index. In two-dimensional arrays, here are some examples of expressions, types, and descriptions. Take a look and review the information below. Multi-dimensional arrays. An array can have many dimensions. If it has more than one dimension, it's called a multi-dimensional array. Each dimension subdivides the previous one into the specified number of elements. Each array dimension has its own length constant. Because each dimension is an array of array references, the array within one dimension can be of different lengths. These are sometimes called ragged arrays. The ArrayList class. The ArrayList class is part of the java.util package utility. Like an array, it can store a list of values and reference them with an index. Unlike an ArrayList object grows and shrinks as needed. Items can be inserted or removed with a single method invocation. It stores references to the object class, which allows it to store any kind of object. ArrayList efficiency. The ArrayList class is implemented using an array. The code of the ArrayList class automatically expands the array's capacity to accommodate additional elements. The array is manipulated so that indexes remain continuous as elements are added or removed. If elements are added to and removed from the end of the list, the processing is fairly efficient. Now, if elements are inserted and removed from the middle of the list, the elements are constantly being shifted around, which could impact performance and the ability to run the script within an acceptable amount of time. Polygons and polylines. Arrays are often helpful in graphics processing. Polygons and polylines are shapes that can be defined by values stored in arrays. A polyline is similar to a polygon, except that it has endpoints that do not meet and it cannot be filled. The polygon class. The polygon class, defined in the java.awt package, can be used to define and draw a polygon. Two versions of the overloaded drawPolygon and fillPolygon methods each take a single polygon object as a parameter. A polygon object encapsulates the coordinates of the polygon. Checkboxes. We've all seen checkboxes, and basically a checkbox is a button that can be toggled on or off. The checkbox is represented by the J checkbox class. A change of state generates an item event. The item listener interface corresponds to item events. The item state change method of the listener responds when a checkbox changes state. The Style Options Program. A frame is a container that can be used to create standalone GUI applications. A frame is represented by the JFrame class. A font object represents by the fonts. Family name, such as Times or Courier. Style, for example, like bold, italics, or even both. And font size. Radio buttons. A set of radio buttons represents a set of mutually exclusive options. So when a radio button from a group is selected, the other button currently on in the group is toggled off. A radio button generates an action event.